Good day, everybody. How are you all? Today we are going to talk about hypothesis test for the population proportion, and we'll use the critical value method. "14% of men said they used exercise to reduce stress. From a random survey of 100 men, it was found that 10 used exercise to reduce stress. Does the sample provide enough evidence that 14% of men in the population used exercise to reduce stress?" So, the solution. So, our null hypothesis or the status quo is P equal to 0.14. And the alternate hypothesis is P not equal to 0.4. N, sample size, is equal to 100. X, number of success, is 10. That means 10 success is defined as the process of reducing stress, by exercising. Okay. So one thing we need to understand, P0, which was the hypothesized population proportion. Population proportion of success. P0 is equal to 0.14. Okay, so let's check N times P0. N is 100 times 0.14 is 14. That is greater than 10. We also check N times 1 minus P0, which if I take the N and distribute it to 1 and P0 inside the parenthesis, I get N minus N times P0, which is 100 minus 14 is 86. That is also greater than 10. Why do we need to check that? We need to check that both N times P0 and N times 1 minus P0 is greater than, both of them are greater than 10, so that we can assume, thus, we can assume that the probability distribution of P hat, which is the sample proportion, is normal, with mean mu P hat is equal to P, 0 in this case, and sigma P hat, which is the standard deviation of the sampling distribution or probability distribution of P hat, is equal to, and this is of course standard deviation. is P0 times 1 minus P0 divided by N. So, let's move this a little bit and okay. So let's calculate a test statistic. Test statistic, which is a characteristic of the sample. Characteristic of the sample. Okay. This test statistic is also sometimes called, standardized test statistic. Test statistic because, which is Z, because we divide as you'll see, we divide the numerator by the standard deviation of P hat. Deviation of P hat. So if I create some more space, let me change the color of the ink. Let's make it this. Okay. So the test statistic Z measures how far the sample proportion P hat is away from the hypothesized population proportion P0. So we have Z test statistic. Okay. Test statistic Z is equal to P hat minus P0 divided by sigma P hat, or equal to P hat minus P0 divided by square root of P0 times 1 minus P0 over N. So let's calculate the test statistic. Now first we need to calculate P hats. So P hat is the sample proportion is X over N, number of success divided by sample size. And that is equal to 10 over 100 is 0.1. Okay. My P0 is the hypothesized population proportion is 0.14. Okay. So before I calculate the before I calculate the test statistic, Z. Okay. Let me formulate the null and the alternate hypothesis. Okay. So the null hypothesis is If you read the problem statement, let me bring it down a little bit. Okay, so P is equal to 0.14 and alternate P is not equal to 0.14. So let's write this down again. 80 is P equal to, don't worry, I'll take care of it. So my 80, maybe I should use a darker pen. What do you say? So my 80 is P equal to 0.14 and my alternate P is not equal to 0.14. Okay. And my test statistic then Z is equal to P hat means 0.10 minus hypothesized population proportion is 0.14. Remember, this is the hypothesized population proportion divided by square root of P0, which is 0.14 times 1 minus 0.14, and my sample size is 100. So again, this is equal to 0.10 minus 0.14 is minus 0.04, and that will be divided by, and I will do the calculations in the calculator. Second x squared gives me the square root. Inside the square root, P0 is 0.14, left parenthesis 1 minus 0.14, right parenthesis divided by sample size of 100, everything under the square root. So this is 0.0346. Okay, so test statistic. Okay, let's calculate this and then I will explain what it means. So I take the inverse of that, 46, actually it is 4698. And this is equal to multiplied by 0.04, which is negative 1.153. So what does the test statistic? So Z, remember Z is the test statistic. So test statistic Z is negative minus 1.15, we might say. That means the sample proportion P hat is located 1.15 standard 1.15 standard deviation of P hat below the hypothesized population proportion P0 of 0.14. Why it is below? The important thing, it is below because P hat is equal to 0.10 is less than P0, which is 0.14. Okay. But is it large enough to reject the null hypothesis? Let's take a look at the problem statement and see if they provided us with the level of significance. Okay, they have not provided us with a level of significance. Okay, let's assume alpha, level of significance, is equal to 0.05. Okay, remember, level of significance equal to 0.05 is maximum probability of rejecting 80 when it is true. This is maximum probability of making a type 1 error. One error. Okay. Also remember, our null hypothesis is P equal to 0.14 and HA alternate is P not equal to 0.14. So this is a two-tailed test because HA contains not equal to sign. What does it mean? Okay, let's draw a diagram of the standard normal curve. So if this is your standard normal curve, that means Z on this axis. And this looks like this. At the center where the peak is the highest, this is mu is equal to 0. Okay, so Z is on the horizontal axis, probability on the vertical axis, center mu equal to 0. And my level of significance is 0.05. And that is the maximum probability of rejecting 80 when it is true, or maximum probability of making type 1 error. Because of the not equal to sign, it's a two-tailed test. That means area of rejection will be divided into two equal parts in two tails. And area of total, let me erase this. We already know from the definition of level of significance, total area of rejection is equal to alpha, is equal to level of significance. And because HA contains not equal to sign, so rejection region will be in both tails. Region will be in both tails. And area of rejection in each tail is equal to alpha by 2. In my case, it's 0.05 divided by 2 will be 0.025. So if I draw this correctly, so this is these two tail regions where we reject 80. Reject 80. And this is also where we reject H0. Okay. And area of this area is alpha by 2. That means area is 0.025. And this area is also 0.025. Total area is alpha. Each area is alpha by 2 in each tail of rejection. Okay. So in the central area, we do not reject H0. Now the question is, what is this critical value minus Z alpha by 2? And what is this Z alpha by 2? Z, what is that? Z alpha by 2. So this is Z alpha by 2. This critical value. Okay. And this is negative Z. Why is this critical value called Z alpha by 2? So Z alpha by 2 is the critical Z value in the right tail, and minus Z alpha by 2 is the critical value, Z value in the left tail. Value in the left tail. Question is, why are they called critical values? Okay, so if I move minus Z alpha by 2 is called the critical value. It is called the critical value, because on the left of it, we reject H0, and on the right of it, I'm talking about this minus Z alpha by 2, we do not reject H0. Do not reject H0. So let me change the color of the ink and explain what's going on. So let me move a little bit up. So I have this, again, the standard normal curve. This is the standard normal curve. That means at the center where the peak is the highest, it's Z equal to 0. On the left area is alpha by 2. This area is 0.025. And also in the right tail, we have 0.025 area where we are going to reject H0, and do not reject H0 is over here. Okay. So what is this Z alpha by 2? Remember, alpha is 0.05 and alpha by 2. Area of rejection in each tail, is alpha by 2 is 0.025. So let's use our calculator. Okay, we'll use the second button, then verse button, then number 3. Okay, and we will do in norm. Number 3 is in norm. Area in the left tail, area is 0.025. Standard normal curve, mu is 0, sigma is 1. We paste, enter and enter. Enter twice. So let's do it. Second button, then worst button, in norm, area in the left tail is 0.025, mean is 0, standard deviation is 1. Press enter and enter. And this critical value on the left tail, okay, this is minus Z alpha by 2 and this is positive Z alpha by 2. So minus Z alpha by 2 is equal to minus 1.96 and positive Z alpha by 2 by symmetry is 1.96. These two are the critical values. Critical values. Okay. So this minus Z alpha 2 is minus 1.96 and this positive is 1.96. So again, if I draw the picture, maybe this time with a different ink, so you'll see the picture clearly. Let me change the color of the ink. Okay, let me erase this. So this is minus 1.96 to the left of it. Reject H0. How did I get this minus 1.6? I plugged in the area in the left tail is alpha by 2 is 0.025. And in the right tail, the rejection region is also, this is also 1.96. And this area is also alpha by 2. This is shaded because there we reject the null hypothesis. And the center is do not reject H0. Now let's look at our test statistics. So if I move the screen up a little bit, you'll see what I have calculated as my test statistic. My test statistic is over here. Okay. So if I may highlight this, this is my test statistic. Okay. So my test statistic is, sorry about that. Let's erase this and we'll get going. So and then I go back on this screen. And type 1 error. So level of significance is the maximum probability of making type 1 error. So my test statistic is minus 1.15. So, so if I move up this last diagram. So let's see. So these, let me make it blue screen. Okay. So at the center, move up a little bit more. My Z is 0 over here at the center. And I have calculated a test statistic of minus 1.15. Okay. And since the test statistic, remember the test statistic is a measure of how many standard deviation away from the hypothesized population proportion is the sample proportion. Since my test statistic Z is equal to minus 1.15 falls between the two critical values of Z, okay, which is do not reject H0 do not, so it is the do not reject H0. Region decision is do not reject H0. If you do not reject H0, then your conclusion is, that means H0 stays. So your conclusion is, at alpha is equal to 0.05. Remember, level of significance, maximum probability of making type 1 error. At alpha equal to 0.05, there is not enough evidence to support HA, because we did not reject the null hypothesis. So our decision was do not reject H0. So if I highlight this is our decision, do not reject H0. And conclusion is there is not enough evidence to support HA because we did not reject HC. And we used critical value method because minus 1.96 and positive 1.96 are the two critical values. Okay, so let me write that down. So minus C is equal to minus Z alpha by 2. Minus Z alpha by 2 is equal to minus 1.96 and positive Z alpha by 2 is equal to 1.96 are two critical values of Z. Why they're called critical values? Because on the left of the negative 1.96 lies the reject H0 and to the right of it lies the do not reject. So you understand the critical value divides the standard normal curve into two parts. One is reject H0, other is do not reject H0. That is why it is called a critical value. And our test statistic of minus 1.15 is between the two critical values. Hence, we do not reject H0, that is our decision, and our conclusion is there is not enough evidence to support HA because it did not reject H0. So, this is called the critical value method. So basically, we used a level of significance alpha divided into two equal parts in the two-tails because this is a two-tail test. The two-tail test comes from the null hypothesis of P equal to P0 and the alternate hypothesis is P not equal to P0, which is 0.14. Finally, we come to the conclusion that there is not enough evidence to support the alternate that P is not equal to P0, which is 0.14. Okay, so I'll stop here today. If you have any question or comment, you can always write me a note. I'll get back to you as soon as possible. And if you like this video, please share with your friends. And if you like this video, please give me a thumbs up. I really appreciate it. And I'll come back next time to show you how to do a similar problem using the critical value method and corresponding. There are two methods. One is a critical value method, the other is the p-value. Next time, I will do a p-value method and you will see how this is done. Okay, so see you next time. Please come back and visit me next time when I'm back to solve this problem using the p-value method. Okay, take it easy. Thanks for watching. Take care. Have a nice day.